Hello, everybody. Thank you for joining us today. We are going to talk low latency and AWS Wavelength with my guest, Navin Katta, who is the Senior Product Manager at Harman. So, whenever we talk about low latency and we talk about connectivity technologies, one of the first thing that comes to mind is 5G. And one of the biggest advantages of 5G over previous generations of mobile technology has been the low latency it provides between traffic and applications. Now, advances in radio technology make that connectivity between your device and the applications a lot faster. But keep in mind that the applications itself are residing on a compute infrastructure that is not as part of the mobile network. So, in order for customers to really take advantage of the benefits that 5G offers, the low latency that 5G offers, you need to make sure that the latency that is introduced in the transit when traffic leaves the application leaves the mobile network and transits to the compute infrastructure where the application servers are, that is minimized. That is when customers can really take advantage of the benefits that 5G offers. And that's exactly what we do with AWS Wavelength. So AWS Wavelength takes the AWS compute and storage infrastructure and places it right adjacent to a mobile network so that traffic coming out of a mobile network can avoid all the transit latency through an internet before it reaches the application service. So it can leave the mobile network and go straight into an AWS infrastructure where the applications are residing. And that enables a lot of new applications that can take advantage of the really low latency that now we can provide between applications and the devices. And my guest, Navin, is going to talk about some of the use cases that AWS and Harman have been working on um, that takes advantage of 5G and this low latency infrastructure that we can offer for edge computing. Now, whenever we talk about the use cases that 5G enables, one of the most commonly talked about use cases is autonomous driving. And it is because it is very latency sensitive. Vehicles need to respond in milliseconds, if not microseconds, to changing driving scenarios or the triggers that come from the external environment, right? And Harman and AWS have been working for quite some time on these CV2X or cellular vehicle to everything use cases that are essentially the precursor to a fully autonomous driving experience later. So I'll start by asking Navin if you can take a minute to introduce yourself, and then we can talk about how 5G and edge computing are an integral part of the move towards autonomous driving or fully autonomous driving eventually.
Thank you, Bala. Absolute pleasure to be here today. I'm Navin Katta. I'm a senior product manager within the Connected Infrastructure Group at Harman. My group primarily focuses on use cases and problems at the intersection of connectivity and ADAS, and as well as automated driving systems. We are responsible for building the next generation of solutions aimed at bringing situation awareness to each and every entity on the road. We do that by using the capabilities of 5G and edge computing and moving latency critical information to AWS Wavelength, where compute intensive applications are hosted. These vary widely from anomaly detection workflows to video analytics using machine learning. For example, we have an ML pipeline that runs video inferencing on the edge. In order for another vehicle or an entity to receive augmented video feed in real time, the inferencing as well as the network latency plays a critical role. So think of a situation where your line of sight is occluded by a huge vehicle in front of you. You're on an undivided two-lane highway and contemplating an overtaking maneuver, for example. Using the pipeline I just mentioned, you'll be able to get a live video feed from the vehicle in front of you right on your dashboard. And this, along with the augmentation that we do on the edge, provides you with enough information on whether to overtake or not. While this is, a showcase application, there are a lot of applications where collaborative perception like this and situation awareness is absolutely critical. Sensor sharing models running on, edge infrastructure will help solve edge cases for automated driving systems that, your current sensor suite cannot address. So yes, 5G and edge computing plays a really critical role when it comes to autonomous driving.
So you talked about some of the use cases that you talked about here. You know, deciding whether to overtake or getting a video feed from the vehicle in front of you where live traffic is not available. Those are vehicle to vehicle use cases. There are also vehicle to infrastructure use cases. Is that correct? Especially for safety of vulnerable road users or pedestrians.
Absolutely, yeah. So at Harman, we are looking at solving safety or mobility problems, not just from between vehicles, but also every other entity on the road, whether it's roadside infrastructure or vulnerable road users like pedestrians and bicyclists. In fact, one of the use cases we have demonstrated in the past involves a pedestrian crossing the street and a vehicle in a conflicting path, with the said pedestrian. And by transporting this crucial location information from both entities, the pedestrian and the vehicle, to edge compute infrastructure using 5G, and then running advanced collision prediction algorithms on edge infrastructure, we are able to notify the driver of the vehicle uh, about the presence of a pedestrian well within the performance requirements for such an application, right? And what you also need to understand here is these are not typical line of sight conditions where other sensor suites on the vehicle can perceive this pedestrian. So this could be a pedestrian coming from in between some parked cars, or it could be from behind a building or wherever else, right? And this helps us address such edge cases and situations. And also, when you think about why this was not done in the past, this kind of performance metrics are not achievable or very hard to achieve using LTE based infrastructure and cloud backends.
So is this, you talked about performance requirement for some of these applications are in the low milliseconds, right? For the trigger to happen. In that case, if you look at a typical reference architecture, you know, what part of your what big part of your stack runs really in the AWS wavelength? And is it fair to say that that edge computing infrastructure is really a critical piece? The connectivity is definitely a critical piece because you need that low latency connectivity to the infrastructure, and that infrastructure itself need to be closer to where this data is coming or where the trigger needs to be sent. Is that a fair representation?
That is correct. AWS Wavelength plays a very critical role in terms of where our workloads and business logic runs. And when we're talking active safety or safety critical applications, you want it to be processed as close to the source as possible. And Wavelength, and in general, the AWS platform makes the task of migrating workloads from what used to be cloud to the network edge a fairly easy process. And the ability to use familiar AWS suite of products like EC2s and whatnot makes provisioning, configuring a very simple task for teams working on it, who would otherwise spend a great deal of time migrating or porting these applications onto other frameworks. This, along with the MNO partners worldwide, the different tie-ups, makes this a pretty good solution for us to work off of. And for Harman itself, AWS Wavelength plays a critical role along with our MNO partners worldwide to bring a solution that's scalable, reliable, and extensible to meet the needs of our customers.
Yeah. Now, you talked about we talked about vehicle to vehicle to infrastructure, a lot of these safety use cases, but Harman is involved in a lot more use cases that are beyond vehicle safety, like the passenger experience or how you can use the distributed infrastructure and the connectivity to provide more than just safety features. Can you talk a little bit
Def-
about that?
Definitely. So Harman traditionally is from the lifestyle world, as you folks may already know, is a infotainment and audio powerhouse, right? And we have a whole slew of brands under us, and we are the in-car infotainment and car audio provider of choice for most of the marks worldwide. And when it comes to connectivity and solutions, this is our next step in identifying the next generation of use cases and how the car is evolving into this third living space of sorts, and what we can do to improve the in-cabin experience, right? So we're exploring use cases like augmented reality, new ways of doing rear seat entertainment, whether it comes to gaming, video conferencing, and so on. But yeah, there's a lot in the works and more to come.
And and given that the car itself is turning to be a software-enabled entity, the distributed infrastructure can also, it has a lot more other use cases, for example, providing updates to your firmware, to your software, because it's in the end, it's a connected entity, and having that distributed infrastructure from which you can, serve these updates, that is that something that you're working on as well?
Yes. So being the TCU provider for various OEMs, security plays a critical role for us, as and we are looking at things like misbehavior detection, identifying misbehavior when it comes to entities on the road, when it comes to messages that are transmitted. The certificate revocation lists, along with tie-ups with different certificate authorities. So all of this plays into the whole portfolio of products that we want to bring in within the connectivity space in the future.
Thank you. That was really interesting talk about how the necessity of having compute and storage infrastructure to complement the advances in latency in the connectivity part plays a major role in bringing a use case such as autonomous driving to market. Thank you, Navin.
Thank you, Bala.